Okay. So, starting this unit with radicals. You need to be able to take a radical and change it into an exponent and take an exponent and change it to a radical. Okay. So, the first thing I'm going to show you how to do is rewrite the expression using rational exponent notation. Who can tell me what rational means?
All real numbers.
Huh?
All real numbers. No, playing.
Even?
Like,
Think ratio, rational. What does a ratio mean?
It's a number to a number.
Oh, but a ratio is part of something.
Fraction!
Well, ratio is a
If we
proportion.
didn't know that, then oh, because it is.
So, these are now fraction exponents. So, instead of raising something to the power of 2, we're now going to raise it to the power of 3/4 or 7/8.
That's a lot of numbers.
Okay, so instead of using whole numbers as an exponent, you're now going to use a fraction. So if we open this up, rewrite the expression using rational exponent notation, then simplify if possible. Okay, so raising something to the 1/2. Okay, so whatever I raise it to, the top part of my fraction becomes the power. So this is 9 to the power of 1. Okay, your bottom part of the fraction becomes the root. So it's 2, which means we take the square root of 9 to the 1st power. That's what that's telling me.
Don't get that.
Oh, because it's like half of the
It's the square root of 9. Okay, so top part of the fraction always becomes the power, and the bottom part of the fraction becomes the root. Okay, so what's the square root of 9?
3.
Your final answer here is 3.
Whoa.
Mm-hmm.
Well, that was easy.
So with the second one, we start off with 8, and this is squared. Okay, because the top part of my fraction is a 2. Then I want to take the cubed root of 8 squared. So that's just how you draw the square root. That's just how you draw the square root. Yeah. Okay. So what's 8 squared? 64. So I actually need to find the cubed root of 64. And that answer is 4.
Will it always be small numbers as the denominators?
To get 64, I would have to take 4 times 4 times 4. So that's how you get 64. I'm gonna show you how to do all this. I promise. We will break all this down. Okay. The last one. X to the third. And this becomes the 5th root. Okay. You cannot solve this one.
Yeah.
You just leave it.
That's
it.
Is there a reason? Whole beans?
There's not enough X's on the inside to pull out. And you'll see what I mean later. I promise. We'll talk about it. Okay. So I can go from a number or a variable raised to a rational exponent. I can also take these and create this. So on the other side, I'm going to show you how to rewrite an expression using radical notation. So we're going to take a number that's underneath the square root and create that rational exponent. So if you open up this side. Okay. The number underneath the radical is 13. We now need to raise that to a fraction. 1 over 5. There, 13 is raised to the first power. There's nothing there. And it's the 5th root, so it's 13 to the 1/5. If there is no exponent written there, it's always an unwritten 1. Okay? Just like if there's a number in front of x, it's an unwritten 1. So 5 would be 25 to the 1/3.
Square root is 7.
Okay. So hold on. This is 7. What's my exponent? 1 over 2. Hold on. We're not finished. It's not completely finished yet. So 7's raised to the first. Remember, parentheses first. 7's raised to the first. And it's square root, which makes the bottom part of that 2. And because that's now raised to the 5th, this becomes 7 to the 5 halves. 5 times 1/2 is 5 halves.
That's what I was thinking to begin with. So I can just multiply.
Yes.
Multiply to the outside.
Sure. So if I would have just given you, this, you would have told me this is 7 raised to the first, and because it's a square root, which means there's no index there, it's a 2. Square root is always a 2. If there is nothing written here, it's a 2, okay, every time. And then all I'm doing is I'm taking that and raising it to the 5th. Well, power over power means to take 5 times 1/2, which gives me 5. Okay. We'll talk more about it, I
I have a
promise.
question.
Yes.
Could I just look at the exponent on the number and multiply by the number on the outside and then put it next to the number?
Yes.
Okay.
That works too.
Okay.
Questions? Okay. Let's talk product rule. Okay. Listen, your rules are not going to change just because I'm throwing fractions at your face. Okay. So, product rule. Product rule said if I have x squared times x to the 3rd, that becomes x to the 5th. What did I do to my exponents? 2 plus 3. Well, guess what? Just because they're fractions doesn't change it. I still add my exponents. So, if you open this one up, okay, so I still add my exponents. So I still need to take 1/5 plus 3/5, which gives me 4/5. X raised to the 4/5.
That's gonna hurt.
Are we ever gonna? Hold on, wait. What?
Are we ever gonna like change it to make it even? Like, say, subtraction. Maybe like
Where you have to change the denominators? Possibly.
Oh, I hate changing.
I can't say that you can't. However, remember you can use your calculator and change it back to a fraction to get your answer. Your calculator will do it for you.
So it's like that. You basically just adding the common denominator.
Okay.
So, I mean, you're probably gonna get to it next, but like, what if it was like 2 to the 1/5 times 2 to 3/5? Would that be like 4 and 4/5, or would it stay 2 and 4/5?
2. Don't let him confuse you. Just stop. Just stop. Stop. Just stop. Yes.
So, like, if it's
like a whole number and a fraction, you keep the whole number, lose the fraction, like once you add them together.
Wait, so give me an example so I can.
Like if you have like x to the x cubed and then like times x half.
Okay, so Kathy wants to know if I have x cubed times x to the 1/2. We still do 3 plus 1/2. But remember, in order to add, we have to change this to be something over 2. So instead of 3, this is 6 over 2.
Because it's over 1, so you wouldn't do the same denominator.
Right. Because right now this is 3 over 1. You have to have the same denominator. So I have to multiply this by 2 to make it 2. What you do to the bottom, you have to do to the top. So 3 over 1 changes to 6 over 2. So then when you add it together, your final answer is x to the 7/2. You just change your whole number to a fraction.
It's okay.
Oh, what's been said too?
Absolutely.
Okay.
Any other questions? Okay, number 8. This is why we did what we did at the beginning. Let's change these to rational exponents first. So this first one should be x to the 1/4.
There we go.
X to the 1/4 times x to the 2/3. So I need to add 1/4 and 2/3. I need a common denominator first. 12.
Wait, no, it's not.
Right. 3 12s.
8 12.
3 12s and 8 12s.
How'd you get that?
Okay. Remember, to go from 4 to 12, I would multiply by 3. What I do to the bottom, I have to do to the top. To get to 12, I multiply this by 4. What I do to the bottom, I have to do to the top. So this actually becomes x to the 11/12.
So when you multiply the bases, you add the exponents.
Yes.
So when you multiply the
Power of a power. We're going to get to that too.
sounds confusing. I mean, not confused, but I get,
Okay. So when I multiply, I add my exponents. Well, what does quotient mean?
it's
Divide.
yeah, that's
So if I multiply and add, when I divide, I subtract. So when I get to a problem like number 9, okay? Okay. When I get to a problem like number 9 and I'm dividing, as long as they have a like base, I subtract my exponents. So 7/10 minus 6/10. X to the 1/10. Why are you getting negative?
Oh.
7 minus 6. Top minus the bottom. Here's my question though. If I would have ended up with negative 1/10, remember you can't keep a negative exponent. So what do I do if I'm left with this?
When you switch it to a
Send it to
decimal.
the what?
Zero.
other side.
Somebody said it.
Scientific
Swear somebody said it.
Oh, you would make it equal to. No.
You
It's
put
to
the
the bottom. It's to the bottom.
To the bottom.
Oh yeah, I forgot.
Right now, this is in the top. To make this even, I just stick it in the bottom. And that changes my exponent. So, if it's a negative exponent in the bottom, you move it to the top to make it positive. If it's negative in the top, you move it to the bottom to be positive.
So you would keep it on first.
Yes.
So always.
Unless they ask you to switch it to radical form.
And that would just be x to 1 different.
Okay. Number 10. This top part is x to the what? 5 over 6. In the bottom, we have x to the 2 over 6. So we take 5, 6 minus 2, 6. 3, 6, which is 1/2. So this is x to the 1/2.
I didn't make us convert it to decimals.
Maybe.
Convert what to decimals?
Yeah, on top.
The 1/2? They're going to leave it rational. I've never seen anything raised to like the 0.5.
So good.
All right. So the next rule was the power rule. So if I had raised to the 3rd, 3 is 6.
I was about to say
X to the
5.
Because remember, this means I take this and multiply it by itself 3 times. So this is technically x squared times x squared times x squared. Well, my first rule told me this is 2 plus 2 plus 2, which is x to the 6.
Oh, so we on negative and 0 rules?
If you can. So like 3, 6, we reduce it to 1/2. All right. So if I open this up, we multiply. We multiply. So this is 3/5 times 1/2. 3/10. Okay. This one is 3/4, bless you, times 2/3. 6/12, which is 1/2. So yes, if you can reduce, please do so. Okay. We've got one more. And we've already kind of talked about this because Teron had already brought it up. Go, Teron.
Technically, not a new school until next year.
Okay. 13. If I just have a 4 and a 9, what's the exponent on the 4? What's the exponent on the 9? So this is technically 4 to the negative 3/2 over 9 to the negative 3/2. Okay. Because you take 1 times the exponent on the outside and 1 times the exponent on the outside. Now, I can't leave these exponents negative. So my 4 needs to go where?
On the bottom.
Where does my 9 need to go?
On the top.
To the top. So this is 9 to the 3/2 over 4 to the 3/2.
I still wrote the negatives.
You're very intelligent.
Yeah, okay, see?
You are super smart.
Heck yeah.
Heck to the yeah.
She just makes very poor choices.
It happens.
What did I do?
Are you drawing pretty pictures on us now? Okay. So if I look at 14, the power rule tells me that I should do 3/4 times 0.
If you look right above it, Bobo.
Okay. So anytime I take anything and raise it to the 0, no matter what it is, your answer is 1. 25 raised to the 0 is 1. X times Y times Z, all raised to the 0, is 1. Okay, so I can give you a big old ugly mess that looks like this. Okay, I can give you something like this. And guess what? Because that entire thing's raised to the 0, it's 1.
So if it's already raised to 0, you can skip everything. It's equal 1, right?
Yep.
But do you gotta put x 0 equal 1? What's
No, just 1's fine. What'd you say now, Kathy?
Was there ever kind of like an extra choice where it's just like x They wouldn't have like A is X, B is 1, because they're the same, right? X is 1. Or those would be two separate answers.
Those are two separate answers.
Really?
So X is not 1, X raised to the 0 is 1. That 0 exponent is what changes it to 1. Okay, that goes on 106.
Okay, so yes. Emma.
Do you have my glue there? Oh, thank you. The
You
bed.
telling somebody, Mama, I gotta turn over what she said, Jack.
106.
That paper that I missed,
right.
do you want me to
I
just
was
go
like,
on the
see what
website and
happened
fill
to
it
you.
out and then show you that I did?
I let somebody use my
That's
phone.
what all that.
Yeah.
No, that's why it's something called deleting.
Oh,
When you get no, it's something called deleting your social media account. Not deleting it, but deleting the app.
wait.
Okay,
Just made that glue smell so good.
okay, okay. So, in order to simplify radicals, which is what I need to teach you how to do, we need to first review prime factorization. Okay, prime factorization. Okay, so you were taught in middle school how to find prime factorization by doing the factor tree. Okay, so I'm going to show you, we're going to go back over the factor tree that you learned, and then I'm going to show you the upside down birthday cake method that we've used before for greatest common factor.
What if we didn't learn?
Okay, so we're going to go over both of them. I don't care which way you choose. Do what you want. It's up to you. So, factor tree method. Whatever number we're factoring, you put first. Okay, I need two numbers that multiply together to give me 120. 2 and 60. That's what I heard. 2 and 60. Okay, are either one of these numbers prime?
Nope.
2.
Yep.
Circle it.
I didn't say that.
This glue does not work.
Okay, 2 is prime, so we circle it. Okay, 60 now breaks down into what?
30 and
2 and 30. 2 is prime, circle it.
2, 15 and 2.
2 and 15,
They're both prime.
circle it. 15 is not prime.
Oh, you said so.
3 times 5.
3 and 5. That's what I meant. And then now it's prime.
3 and 5. 3 is prime and 5 is prime. So your prime factorization for this is 2 times 2 times 2 times 3 times 5. That's it. As soon as everything is prime, you're done.
Well, I guess there more things too. Do you have to do all the factors that equal 120? Or just
I need it in its prime factorization. So I need prime numbers, all prime numbers that multiply together to give you 120.
all right.
Yes.
Do they have to go in order?
No. My suggestion though is when you write them out, if you've got 3s, put all the 3s together, put all the 2s together, put all the 5s together, put all the 7s together.
But like
Okay.
the 7 could be first.
But the 7 can be first. You can have like 7 times 2 times 2 times 2 times 5. It doesn't matter. Okay. All right. The other way is called the birthday cake method. Okay. We did this back with greatest common factor. Okay. So the only issue with birthday cake method is the numbers that you divide by have to be prime. I can't divide this by 10. 10 is not prime. You have to divide by prime numbers. So what is a prime number that divides into 120?
2 and 60.
Let's do 3. Somebody said 3. 3. You're left with 40. What's prime that can divide into 40? 2 And that leaves me with 20.
I like this one better.
What's prime?
2,
2, and that leaves me with
10, and then 2,
2
and then
and 5,
and that's it.
5 and 1. Do not stop until you are at 1.
Dang it.
And look, you got the same answer that you got from the factor tree. There are 3 2s,
How's it stand for right there?
a 3, and a 5. They call this the birthday cake because I can flip it upside down and it looks like a tiered cake and you can put like a little flame on top like it's a candle.
But they could also call it stairs for bird view.
Period.
Okay.
Okay. So I personally do not care which method you use, but you need to use one of these methods to be able to create prime factorization. Questions?
No.
Okay, 107, friends. We are busting through.
Busted.
Bust down. Don't make your student bust down again.
Oh, let's do it.
Y'all be jealous.
We will. We will.
Yeah.
I think you should do it for Jackie's birthday.
I should bust down for Jackie's birthday?
Yeah, you should.
Stop, Miss Vector.
Like you said, heck yeah.
Yeah.
All right.
This record doesn't do.
On the top of page 108, okay?
I'm sorry.
Because I'm so sweet and kind,
You gave us the answer.
these are all of the prime numbers
1 through 100.
between 1 and 100. So if you use the birthday cake method, you cannot divide by any number that is not on this list.
Period.
Period.
No.
So you want us to glue this at the top of the
So glue this in the top of page 108, and underneath of it, we're going to glue in that little booklet once we're done with it. Okay, so both need to fit on that page. We're on a roll and we ain't but.
And what page is this factorization thing on?
Page 107.
I thought so.
Yes.
That was weird.
All right. So, how many of you prefer birthday cake method?
Wait, no.
I like eating birthday
I like
cake.
either. I like either.
How many of you prefer factor tree?
It looks cooler.
Me.
Oh, God.
So it's not choosing.
Right, birthday
Hey,
cake
we're
is.
going to have birthday cake.
I like birthday cake.
All right. So, since majority likes the factor tree, I'm going to stick with the factor tree.
Heck yeah, man.
Okay. If you prefer the birthday cake, I want you to do the birthday cake and compare your answers against mine. Okay. That is okay. So, factor tree. 48. Sorry, we're on the front page of the little booklet. We're on the little booklet. What did we get for your birthday? Oh, we got some Cheetos.
That's big, Miss. I don't know. I'm gonna do a big. I'm doing it here too. That's humongous.
I know she didn't open it.
No, she just took it.
You gotta ask Allie. Allie gave it to me.
What?
I took the watermelon ones too. Okay. What multiplies together to give me 48? 6 and 8.
Hold on, that's not what my book look like. Oh yeah.
Yours.
Is either one prime?
No.
No.
What page?
So 6 is 2 and 3. Are they prime?
Yeah.
Yes. What about 8?
4 and 2.
4.
And 2 is probably not.
2 is prime.
4 is 2
We
and
can
2.
go 4, 2,
So
and
that's
2.
4 is 2 and 2.
Period.
Prime, prime. So 2 times 2 times 2 times 2 times 3. And mine will always be in order from smallest to biggest. That's just me. I'm sorry. So you should have 4 2s and a 3.
It's very comforting to look at.
I hate the factor tree.
I like factory better actually because
I don't like it. It seems like everything's here.
with the birthday cake you gotta Think of only prime numbers, right?
Yeah, but see, I stick with like 2, 3, and 5.
We should
Yes.
also.
Mostly everything's divisible by 2, 3, and 5. Okay, 38. 2 and 19. 2 is prime. 19 is prime. Guess what you done? 2 times 19. Period.
Period.
Okay.
No Capalapa.
No-
No Capalapa.
No Kapalapa.
That's
No
my thing.
Capalapa.
I invented that.
Oh, you invented no
Can you
Kapalapa?
spread the word in your other classes?
Okay.
We're trying to go make Allie go famous.
So, Allie's going viral right now. Her new phrase is no Kapalapa.
This is what we say forever and ever. Thank you.
Period.
No Capalapa.
Okay, flip the page.
11 and 8.
Okay, so Tay says let's start with 11 and 8. 11 is prime. 8,
4 and 2.
2 and 4. 2 is prime.
2 and 2.
2 and 2.
So it's 11, 2, 2, 2.
2, 2, 2, and 11.
So they can't go out of order?
Yes. My suggestion though is if you have more than 1 2 to put all your 2s together, put all your 3s together, so on and so forth.
Fire.
Bust down.
Uh,
102.
Jams.
51 and 2.
Hey, they both
I just
prime,
noticed what
You said they're both prime, you heard?
Oh,
No,
no.
they're not.
17 and 3.
You said 17 and 3.
Now.
Now they're all prime.
Oh, yeah, you can do 17.
How do you know it? Answer me this. How do you know a number is divisible by 3?
If you add
Divide
them
it by
together, then they
3
can
and
be
see
divisible
if you
by
get a
3.
decimal.
Wait,
Just
what?
one, 3.
Okay,
If you
so-
don't get a decimal, then
We know that 51 is divisible by 3. What's 5 plus 1?
6. Oh, wait, never mind.
If this number is divisible by 3, this number is divisible by 3.
Oh, that's crazy.
So, if I give you 132, what's 1 plus 3 plus 2?
6.
If this is divisible by 3, this is divisible by 3.
Can I write that on the top?
I don't care.
Somebody could
Nobody
tell
taught
me.
you these rules.
No. I just learned the thing about the what's the word? The 9, the 6 finger. Oh, yeah.
4,071. What's 4 plus 7 plus 1?
12.
Divisible by 3.
This number is divisible by 3.
God.
Learn something new every day.
No, seriously. It just class. Put your jacket on now. I don't write. Your armpits are not.
Okay. 147.
You can do it.
147.
7 and 21.
7 and 21.
7,
7.
3, and
And 3.
7.
3 and 7. Prime. 3 times 7 times 7. And finally, 65. 5 and 13. That's it. Okay.
It's easy. Let's not say that.
Hey,
Hey,
yeah, go
look
ahead,
at
go
that.
ahead. Hey!
Okay. This goes in at the bottom of page 108.
Yeah, we heard clearly. Hear it. I think I just need to get shot one at a time. You know, just pound like this. Ow, not like that. Good. No.
Oh.
That's not how it
You said this blue is on page 108?
Yes.
Let's go on 109.
It hurt. I was with a gun.
You heard? Yes. Huh?
I would die.
Everybody don't say that.
Die.
All of them.
Be like,
100 going
I know what that was. Let me some lotion.
But those are my So this goes on 105. This goes on.
Okay. So here's where we get into the nitty gritty. This is what I need you to focus on. Okay. Everything we've done up till now is the basics for what you need to have for this. Okay. So we need to talk about the parts of a radical so you are able to simplify them. Okay. So obviously, this square root symbol, this is called your radical symbol.
that's right, dude.
It's rad. Hey. Tubular, dude. Okay.
I'm done now.
Got nothing to nobody.
Okay, so
Every radical will have something underneath of it. So it can be something like 125 x squared y to the third.
Okay. Wait a minute, dude.
So you're going to have a number. You're going to have variables underneath that radical symbol. Okay. What is underneath the radical symbol is called the radicand.
Radican?
I really can.
Never say you radicate.
Because you radicand.
y'all, yeah, y'all smart.
Oh, the cheesy math joke. I love it. Okay. So the little number that we wrote, the cubed root, the fourth root, okay, whatever number is written here, and it's a tiny number, this is called your index. Okay, this is called your index. That tells you how many numbers or how many variables you need to multiply together. Okay. If your index is not written, if you just have the square root symbol, your index is automatically a 2. If the index is not written. So, in other words, if you see something that it looks just like this, your index is a 2. Okay. If you have nothing written there, your index is a 2. That is square root. Okay. If I change it to a 3, it becomes cubed root. If I change it to a 4, it becomes the fourth root. Okay.
That would be the fifth.
Yes.
Or like, okay.
6th root, 7th root, 17th
So there's no
root.
words for those.
Nope. Okay. You also can have a number out front that multiplies. So, like when you had 2x, 2 was called your what? Coefficient. These also have coefficients. So, I can have something multiplied out front, and this is your coefficient.
I know you're proud of me. It's okay.
I am proud of you. Did you just say you can't spell coefficient?
Boy, I'm on yours. What'd you say? Oh, was that you that said that? I can't spell it.
Okay, I'm going to skip the instructions on the bottom of this because the same instructions are on the front page of the next one. So please clue this in on page 109.
Then you're gonna fail your life.
Harley, you already
Dang! I know, and like I don't understand why. Where did I go wrong? Emma, what?
No, you went wrong.
Oh, you're right.
It's because I moved and we stopped being friends.
I was just playing.
She's right.
I was just playing.
Harley, it's because I
I was just playing.
No, it's not so bad. I miss you. I've never been so much.
I miss you too.
Y'all both lying to each other. It's all right.
Okay.
What? I miss you, Emma.
Oh, you moved houses?
Yeah. We usually get to
Okay, I'm going to read these instructions to you, although most of them are not going to make sense right now until we actually do some
The
examples.
first one don't make sense.
So,
You don't. I'm just playing. Sorry.
beach. All right.
They don't.
Number 1 says, you want to find the prime factorization of your radicand. So everything underneath the radical you need to break down by the factor tree or by the birthday cake method. I don't care how. 2, determine the index. Okay. Number 3, we're going to start circling in groups of the index. The number or variable from each circled group will show up outside the radical symbol 1 time. Anything left uncircled will remain under the radical. And then we multiply everything that's out front together and everything that's underneath together.
Woo, chili.
Woo! Let's do this. Yes.
Oh, 110.
This goes in on 110. Oh, yeah, we do a radical.
Ain't nobody dying.
They're not. We're not doing word problems. All right. So we're going to start you off nice and easy. Then we're going to get into the ugly. Nice and easy.
Okay, can y'all shut up or no?
That just means I'm not answering questions later. Because if you want to like talk and not focus, I don't really care.
Yeah, sure.
Okay. So what is underneath my radical symbol? 45. Let's break it down. 9 and 5. The 5 is prime.
Why did I say radical?
And 9 is 3 and 3. Okay. So my prime factorization is 3 times 3 times 5. Okay. Everybody good to this point? Okay. You need to now look at this. What is my index? 2. There's nothing written there, so it's square root, so my index is 2. Okay, so what this means is you're going to look at your prime factorization and see, do I have 2 of something?
Yes.
Yes.
3.
3s. So I'm going to circle my 2 3s. Is there anything else in 2s?
No.
No, so I'm done circling. Okay, so what I have circled comes out front. I've got 1 circled group of 3s. So I'm pulling 1 3 out front. Just 1. Your 5 is not circled, so that goes back underneath. And you're done.
Whoa.
Oh my God. Yes.
When you get to the point that stuff on the outside, like the exponent.
What exponent?
Like 2 pages ago, like these. That's like the
You're really only going to apply to that if they tell you to take this and break it down into rational exponents. So this would be like 3 times 5 to the 1 half.
No, you wouldn't touch the face.
Okay. Take a look at this one. We need to break down 288. 12.
I'm just playing. You probably can do 12.
Well, you probably can do 12, like 12 and 4. Nah.
2 144.
12.
Yeah, 2 144.
2 and 144. Okay.
And now that's 12 and 12, buddy.
144 is 12 and 12.
4 and 3.
4 and 3. I almost circled 12s.
And 4 and 3.
And 4 and 3.
It's a prom. 2 and 2. The 2's a prom. Heck yeah.
Heck
I'm
yeah.
in a really good mood today. And
I see this.
are you going to say I ruined it? No. Oh, I was going to say, don't you? That's right.
It's her birthday. It's a good thing she's in a good mood.
Heck yeah, it is.
Okay.
I'm
So,
gonna
288, we've got 1, 2, 3, 4, 5 2s. 1, 2, 3, 4, 5 2s. 2 3s. Yes, here and here. Okay. I also look at my variables. X squared means I have 2 x's. And y to the 4th means I have 4 y's.
Wait a minute, cause
X squared is x times x. Please don't act like you don't know what that means. Y to the 4th is 4 y's multiplied together. Okay. What is my index? 2 again. Okay, my index is 2. And I am running, that's dead. Okay, so my index is 2, which means I'm grouping in 2s. So I've got 1, 2. I can circle some 3s. I can circle some x's and all of my y's. Period. Okay, so my index tells me how many need to be in a group. Okay, so out front becomes 2 and another 2 and a 3 and an x and a y and another y. Underneath the square root is what is not circled. 2. Okay, my last step is I need to multiply everything out front and multiply everything that's inside. So 2 times 2 is? Times 3 is? 12. So this is 12x y squared, square roots of 2.
Heck yeah, we got the answer.
I feel smart.
I'm dying slowly, y'all.
Okay, so let's look at this next one. 64. 64. 8 and 8.
4 and 4.
4 and 4.
And 2. 4, 2, 4, 2. I'm retarded. I swear.
We've noticed. It's okay. 2 and 2. 4 breaks down into 2 and 2. And 2 and 2. So I have 1, 2, 3, 4, 5, 6 2s.
Too many.
There's never too many 2s.
All right.
Okay. Watch this though. How many x's do I have?
10.
Woo!
This is ridiculous.
1,
Right.
2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Make me lose count. 1, 2, 3, 4.
Don't worry, because when we're finished with this, I'll show you the short game.
Oh, you oh my goodness, start us now. Come
What?
on.
What?
You think this is funny, Miss Smith? Because it's not funny.
Just love my life. Let it go.
Living your best life.
Right.
I wrote like that. You wrote it like this. Oh.
I like how my mom would say, "Are you living your best life?" I was like,
Okay.
Why not?
I gotta.
What is my index?
4.
4. That means I need to have 4 in a group. So here's some 2s. Here's some x's. Here's some more x's.
Yeah.
Here's some y's.
And there's some lines.
And some more y's.
Right there.
Okay. So I've got a 2 out front, 2 x's, and 2 y's. And back underneath the 4th root goes 2 2s, 2 x's, and 2 y's. So we're going to finish this off. This becomes 2x squared y squared. The 4th root of 4x squared y squared. Oh, damn.
Take everything from there and put it in the radical.
Everything that's not circled. Okay. Everything that is not circled. Okay. So, I know it is a pain in the butt to write out 10 X's, 10 Y's. So, watch this. Watch and learn, my friends. I got you. Okay. X to the 10th. Okay. What am I circling in? Groups of 4. So, what's 10 minus 4?
6.
What's 6 minus 4?
2. Oh my god.
Can I subtract again?
No.
No. So, I subtracted 1 2 times. X to the 2nd came out front.
Okay.
How many X's are left? 2. Back underneath.
Whoa.
I'm gonna do it the other way because that confused me.
Yeah, just a little bit. You
That's
can-
why I stick with this.
Oh my god.
And if you're good at the shortcut, you're welcome to do the shortcut. So in other words, if I have X to the 31st, and I'm trying to take the 5th root of that. Okay? What's 31 minus 5?
26 something.
Minus 5.
21.
Minus 5.
16.
Minus 5.
11.
Minus 5.
6.
Minus 5.
1.
Four, 5, 6. So out front is X to the 6th. Back underneath is X to the 1st.
That would be the whole answer.
It was a fraction with it's like
Oh, I'll like
I had to get
Okay. We got 3 more. 3 more, 3 more, 3 more. Square root of 64. If you have to break this down, we might have to fight. 8.
8.
My suggestion to you is memorize your perfect squares. 1, 4, 9, 16, 25, 36, 49. We're at 64, 81, 100, 121, 144, 169, 196, 225.
You only have to go all the way to 2, all the way to 25. Like 25 squared.
I'm not saying you have to have them all memorized, but I'd have the basics memorized. You should at least be able to go to like 12 squared. Okay.
1, 6, 9.
Okay. So the cubed root. So we're breaking down 16. 4 and 4. 2, 2. 2, 2. So this is 2 times 2 times 2 times 2. I've got 2 X's and 5 Y's. And you said my index was what, Tay?
3.
My index is 3. So we're grouping in 3s. So I've got a set of 2s and a set of Y's. So 2 comes out front, Y comes out front. Back underneath the cubed root goes 2, and this is X squared. And 2 Y's left over makes this Y squared.
Oh my.
because it's 2 times x, which makes it 2x squared. And y times y makes that y squared. Okay. Last one. Okay. Last one. We're breaking down 64. 2 and 32. 2 and, thank you. Whoops, I did not mean to circle that. 2 and 8. 2 and 4. 2 and 2.
You want that fast, yo.
3, 4, 5, 6.
So there are 6 2s. 1, 2, 3, 4, 5, 6. 3 x's. 7 y's. 6, 7, and 3 z's.
It had to be a Z.
What's my index? 5. I've got more than 5 2s, so I can circle some 2s. I have more than 5 y's, so I can circle some y's. So out front goes a 2 and a y. And back underneath the 5th root is 2. I've got 3 x's, so that's x cubed. I've got 2 y's, so that's y squared. And I have 3 z's, so that's z cubed. No. Normally, they're going to put the answer in alphabetical order.
Wait, don't turn it off.
Okay. So normally when you're dealing with math, it goes in numerical order and alphabetical order. That's just how things go.
Yeah. Because you're already doing enough work, so.
Wait, what did we put? This one? Just 8?
8.
Kelly gonna be upset when she comes back tomorrow. Don't know what we're doing. So,
Okay.
110?
Yes, that goes in on page 110. So, ladies and gents, your homework for this evening is IXL, Algebra 2, L4, and L5. L4 and L5. Okay, so L4 is going over simplifying radical expressions, some basic ones.
If you don't, or can you email this to me?
Okay, write it down and simplify. L4 and L5.
Say that in the video. Say L4.
2.
Thank you. I did that.
We haven't done yellow